We are now going to talk about ray diagrams for convex lenses. So we always choose a thin lens. Thin lens means that the difference or the distance between this side and this side is very small. So this distance is very small. So as a result, if you write pole of the lens right in the center, it is same as taking the pole on the red side or pole on the green side. So this is a refracting material, and we call it a convex lens because just like concave mirror, the light falls on the red part. So light is falling in this direction, and in convex mirror also the light falls on this protruding red part. But in this case the light will not get reflected back, but it will get refracted through the surface. So there are a couple of things we need to notice or take point of. First of all, you always have to keep in mind the focus. So you keep in mind the focus right here and this pole P or the center of the lens. So these 2 points are extremely important for us. So you have to draw these 2 points first. So we are going to do 5 cases for convex lens. The first case is you keep the object just behind the center. So the first ray in orange, it goes parallel to the principal axis. Again, the principal axis joins the center of curvature C to P. So this line here going all the way, this is the principal axis. So let us write this down. This line is the principal axis. So this yellow light or this orange light goes parallel to the principal axis. Now once it passes through the lens, it will now bend to go through the focus. So it passes through the focus. Now this purple beam, this passes through the center of the lens or the pole. So once it passes through the pole of the lens, it does not change its direction. So anything which passes through the center of the lens will not get refracted, because its angle of incidence is precisely 90 degrees. So this will pass straight through the lens, and that's why this ray is passing straight. Now it goes right here, and where these two rays intersect, where the orange and the purple ray intersect, you will get the image, and that's how we draw the image. So see, the point of intersection is below the principal axis, so the image would be inverted. Now we take case 2. So case 2, we again mark the focus here, the center is here, focus here, and center here. This is the center of the lens. So the first ray goes parallel to the principal axis. Once it goes through the lens, it will bend down and pass through the focus. The second ray goes through the center of the lens, so it does not bend anything, it just goes straight. And these two rows intersect right here, and this point of intersection is below the principal axis. So again, this line joining P and C, this is the principal axis. And we get an image here. Now we talk about case 3. Now you are between center and focus. So again, focus is here and center is here. So the first beam of light we are drawn in orange, goes through the lens, bends so that it goes through the focus. The second beam of light is purple. It goes through the center, so does not bend or anything, goes straight. Both of them intersect. You intersect below the principal axis, and that's how you get the image in light green. Now case number 4 is that you bring this object on the focus. Now again, there are 2 beams of light. First beam goes through the lens, bends, passes through the focus. The second beam of light just passes through the center of the lens, doesn't change direction. Now these two lines that you get, these two lines are parallel to each other. So these two lines are parallel to each other, and therefore you will see no image. So no image is formed since the lines do not intersect. Now case 5, you move the object. So this is the object in dark green. So this is the object, and now the object is between the lens and the focus. So the first ray of light we'll draw in orange. It goes like this, passes through the mirror, bends, and goes through the focus. The second light, which is in purple, this purple beam, this passes through the pole of the mirror, therefore it passes unperturbed. So if the human eye is here, so to this eye, these two rays of light appear to be coming straight. So straight means they are coming from some point farther away. So we extend this orange line backwards. We also extend the purple line backwards, and we see both these lines intersect here. So this is here we get the image. So this is the image. So notice that the image seems magnified and it is behind the lens. Notice that angle of intersection is above the principal, therefore image is erect. This is a common lens which is used for magnification. So if you put your hand behind a convex lens and you bring your hand between the focus and the center of the lens, you will see a magnified image of your hand, and that is precisely because of this case 5. So this is the light green is the image that appears. Now we talk about concave lens. Now concave lens, it appears like this, and the idea is that the light falls on a concave surface. So light is coming in this direction. So in a concave mirror and a concave lens, the light falls on this curved part like this. So that is why this is called a concave lens, as you have a concave mirror, because the light is coming like this and falling on such a surface. So in concave mirror, the light would reflect back, but here the light passes through. So first notice that you pass through the center of the lens or the pole of the lens, and that is this purple light. So you have the object here, you have the focus here, center is right here, and the length or the distance of focus from the center of the mirror is f. So this is a thin lens. So again the purple light will pass through the center of the mirror undisturbed. Now we focus on the orange light. So the yellow beam of light goes through the lens and gets refracted, and it changes direction. So this refraction, if you trace this refracted ray back, so we are tracing the path of the refracted ray back, and you see it appears to be coming from the focus. Now you look at the point of intersection of this purple ray and this refracted ray. Both of them intersect right here. Notice that the point of intersection is above the principal axis, so you get an image, and the image is erect.